Hello class, in this video I'll be discussing percent composition, empirical formula, and molecular formula. Okay, let's start. As you recall, there are three fundamental laws, and one of which is the law of definite proportion. Definite composition. So it states that the element in a compound is present in definite proportion by mass. So say for example, H2O, the ratio of hydrogen and oxygen will always be two hydrogen atom and one oxygen atom. So this is definite. Okay, so that is our basis in solving for percent composition, empirical, and molecular formula. So when we say percent composition, this is how much in terms of percent is an element in a compound. Okay, so the percent by mass of each element in a compound. How do we solve that? We just divide the mass of the element, the molar mass of the element in the compound divided by the total. Okay, example here, determine the percent composition of the element in the compound glucose. So we have here this, and you already know how to find the molar mass. Step 1 is to find the molar mass, then solve for the percent composition. So let's find first percent composition. Okay, so we have C6H12O6. So C6H12O6. So we find first the molar mass. So C, H, and then O. So we have 6, 12, and then 6. That's the subscript. Multiply by the mass. We'll use whole number 12, 1, and then 16. Then add that. I'll multiply first. This one is 72, 12, and then 96. So add this. So that will be 180 gram per mole. So next, to find the percentage, we calculate the percent of carbon, percent of hydrogen, and percent of oxygen. So that will be equal to the mass, which is 72, divided by the total, 180. Okay, this one is also 12 divided by 180, 96 divided by 180. Then we multiply it by 100. Since the units will be gram, so we'll cancel the units. Okay, so solve that. This will give you 40.00%, 6.67%, and then 53.33%. The allowable total is 99.99 or 100.01. Okay, so since this will be equal to 100%, so that's correct. So that is the percent. So this means that oxygen has the highest percentage in glucose. Okay, so that one is easy. Okay, let's try another one. A washing soda is used in manufacture of glass, pulp, and paper. Find the percent composition of each element. So that will be, okay, percent comp Na2CO3. We find first the molar mass. So we have Na, C, and then O. This is 2, 1, and then 3 times Na is 23, carbon is 12, and this one is 16. Okay, 46, 12, and then 48. So that will be equal to 106 grams per mole. Then we find the percent of sodium, percent of carbon, percent of oxygen. So that will be 46 over 106 12 over 106. 48 over total 106 times 100 equal to 43.40%, 11.32%, and then 45.28%. Okay, so that's it. That's for the percent composition. So for your practice, you can try to solve the percent composition of this potassium manganate. Next, let's talk about empirical formula and molecular formula. So when we say empirical formula, it's the simplest whole number. So basically, this is lowest term. While molecular formula shows you the exact number of atoms before you simplify it to lowest term. Okay? So example, this one. The empirical formula of benzene and acetylene are the same, but the molecular formula shows you the exact formula. C6H6, C2H2. Okay? So that means this one again is in its lowest term, and this is it has multiplier. Okay, so we'll start with finding the empirical formula. So for empirical formula, the given will be percent. Okay, the percentage. So first to convert the percent to grams, and then convert the grams to moles. Then after that, divide all the moles to the smallest mole value. Then change the integer to the subscript. Okay, let's try this. What is the empirical formula of a compound containing this? Let's add one black. Okay. Okay, so step 1 is to convert the given to grams. Okay, so percent to grams. We'll use 100 grams as an assumption so that it will be easy to convert. So if we have 100 grams, 70% of that is also 70 grams. Okay, so the assumption will be 100 grams. So basically, that will be Pb, carbon, and oxygen. So that will be equal to 70.19 grams, 8.14 grams, and 21.67 grams. Okay, then we convert these grams to mole. Grams to moles. How do we convert that? We multiply this by their molar mass from the periodic table. Kukunin sa periodic table. So, how much is that? Pb in the periodic table. So, bring out your periodic table. So, Pb is 207. So, 207 here. Then 1 mole on top. 1 mole, 12 grams. 1 mole, 16 grams. Okay, so that's coming from the periodic table. Okay, we can change this to this so that it would. Okay, so cancel the grams, we're left with moles, and what will be the answer? I think I have calculator here. So that will be 70.19 divided to 07. 0 point. This time, let's have first the 4 decimal places. So, 0.3391 mole. Next, 8.14, 12, 0.678. Then we have 21.67 divided by 16. 1.354344 mole. Okay. Then the next step is to divide it by the lowest. Okay. So the lowest will be this one. Okay. So take note of the steps. We divide this by the lowest, which is 0.3391 mole. 0.3391 mole. 0.3391 mole. Okay, and then the answer will be whole number. So obviously this is 1, this is 2, and this one will give us divided 1.3544 divided by 0.3391. So 3.99 or approximately 4. Okay, and that number, those number will be the subscript. So that will be PB sub 1 C2 O4. But because we don't write the 1, so that will be PB C2 O4 as the empirical formula. Okay, so that is the answer. So again, step 1, convert first to grams and then convert to mole. You get this in the periodic table. Then once you get the moles, you divide it by the lowest of these three. This, and the lowest is 3391. Okay, but there are exemptions to the rules that you have to also remember. Okay, so that's the answer. So take note that the mole ratio, when you divide all the moles by the lowest, if the answer or the molar ratios have decimals such as 0.33, 0.25, 0.5, you do not immediately round it off. Okay, you multiply the entire formula with something that will make it a whole number. Example, let's just have A sub 1.5, B sub 2, C sub 1. Okay, so with that, you have to multiply this. You don't round this off to 2. Okay, you multiply the entire equation by 2. So the empirical formula will be A3, B4, C2. And this is correct. Okay, so if you write A2, B2, C, this is wrong. Same with 0.33. If you have x 1.33, y sub 1, you have to multiply this by 3 so that this becomes 3.99. So x sub 4, y sub 3. Okay, the entire empirical formula. Okay, not just this one. You write the empirical formula and then that's the time for you to multiply it by 2. Okay, let's try this. And then for the molecular formula, we'll look for the subscript. I mean the multiplier. Okay, let's try this. Okay. P Okay, step 1, to convert it to grams. Okay, so P becomes 43.64 grams. O 56.36 grams. Okay, these are the given, and then we also have there the molar mass of the compound. Okay, so we'll use that later. Next step is to multiply this by its molar mass. So gram and then mole, and then this one is gram and then 1 mole. This will be coming from the periodic table. So oxygen is 16, phosphorus is 31. Okay, let's solve. So 43.64 divide 31, 1.407. Then 56.36 divide 16, 3.5225 mole. Then we divide it by the lowest. So the lowest is 1.4077 mole. 1.4077. So this is 1. And then the 3.5225 divided by 4077. 2.5. Okay. Since it's 2.5, we can immediately round it off. Okay, so this is an example of that. So you have to write P1 O 2.5, then multiply this by 2 so that it becomes a whole number. So this will give you P 2O5. So this is the empirical formula. Okay. Okay, so take note of that. Okay, now there's also a molar mass of the compound. Okay, so we'll use that for the molecular formula. So to find a molecular formula, you have to get first the mass of the empirical formula. You'll be needing the N. N is equal to the mass of molecular formula divided by the mass of empirical formula. So since the mass of the molecular formula is on the problem, what is that? 425.82. 425 gram per mole. We have to find the empirical formula. So that's P2O5. So P is 2 times 31. O is 5 times 16. So this will give us, let's add 31 times 16 times 5. So 142 gram per mole. So we'll divide that 142 gram per mole. So N is equal to 425.82 divided by 142. So 2.99. Approximately 2.99 or 3. So the 3 will be our multiplier. So we have to multiply the P2O5 by 3 to get the molecular formula. So that's become P6O15. Okay, so that's it. That's an example for the molecular formula. Okay. Okay, that's it. Sample problem, another one for AM. This is for your practice. Okay. Okay, last example. So, caffeine found in coffee and tea contains this given. Its approximate molecular mass is 194.1. Find the molecular formula. So, before we get to molecular, we have to find first the empirical. So, we start by converting to grams. So, you have C, H, N, and O. Okay, so the given will be 49.50 grams, 5.20 grams, 28.8 grams, and then 16.5 grams. Okay, next is to convert this to mole, get the periodic table. So 1 mole, so we already know 12 grams. Hydrogen, 1 mole, 1 gram. Nitrogen, 1 mole. How much is nitrogen? 14 grams. Then oxygen is 16 grams. 1 mole, 16 grams. Then we multiply and then divide. Cancel the grams. We're left with moles. So that will be equal to. Okay, just solve that. So 49.5 divided by 12. 4.125. Then 5.20 divide 1, so 5.20. 28.8 divide 14. 2.057. 16.5 divide 60 equal to 1.031. Okay, then next is 2 divided by the lowest divided by so this one is mole, divide by 1.031 because this is the lowest. Use color. Okay, so this one will be approximately 1, actually equal to 1. This one is 2, this one is 5, and this one is 4. Okay, so our empirical formula will be C4 H5 and 2O. Okay, so this is the empirical formula, but we're looking for the molecular formula given this mass. Okay, so we'll have N is equal to mass of molecular formula over mass of empirical formula. So we find first the mass of the empirical formula. So C, H, and O. So 4 times 12, 5 times 1, 2 times 14, 1 times 16. So this one will be 4 times 12 plus 5 plus 16 plus 28. What's that? There, 97. So 97 gram per mole. We'll use that here. So the mass of the molecular formula is 194.1 gram per mole. That's from the given. Here, divided by 97 gram per mole. So N is 194.1 divided 97. So 2. So N is 2. So we'll use that to multiply our empirical molecular C4, H5, and 2O times 2. So our molecular formula is becomes okay, C8, H10, N4O2. Okay, there. Okay, so that's it. Okay, and here, try to solve other problems. So these are practice exercises that you may solve. Okay.